Hello. For this exercise, we are going to be looking at invasive species around Alaska. And some of the big questions that we're looking to answer are, what campgrounds need to have money devoted towards invasive species removal? So looking at, which campgrounds have invasive species, say within a 1 mile buffer of the campground, which campgrounds have the most, the highest count of invasive species within a 1 mile buffer. And then we're going to explore the effects of roads and trails on invasive species distribution and the limitations of being able to do that in the state of Alaska. And then just a hypothetical, let's say that they're putting in a chain of cabins around Juneau. And so as a planner, what route might be the best route for a road or trail, based on you don't really want to go up steep slopes, which they have some of those around Juneau, and thus you can look at what might be the hypothetical area that could be affected by invasive species, and is that going to be a sensitive area potentially? So those are the three big questions that we're going to be looking at. We're also going to introduce you to a lot of different data sources here, some non-traditional data sources, and also just kind of talk about how, spatial analysis doesn't always have to be whiz-bang fancy tools. A lot of the more powerful work is done with simple tools and just understanding how to manipulate the data. Understanding spatially how it all fits together, and if I use this tool, it would result in this kind of output, and would that output really answer the question I'm trying to ask? So it's really, more of a thought process than the latest and greatest. Another thought is that you can do a great analysis, but if you can't relay that information to the public, or your intended audience, then, what good is your analysis? You've got to get it out there and get it in the hands of decision makers and the public. And so I'll show you this Color Brewer website that I use, which is developed on the basics of cartography, so map making and color science, and can help inform you as far as what is the appropriate color scheme to use for your map. And then I will go over some hints as far as how to make your life easier in ArcGIS Pro. When you have a lot of layers on in your table of contents, you can easily turn multiple layers on and off. If you click, on all the layers that you want to turn on or off, or, click at the top layer, hold down the shift, click at the bottom layer, so that they're all selected, you can just hit the space bar to turn them all on or off. And the same type of process for collapsing layers. If you want to collapse a whole bunch of layers at one time, you can just highlight all the layers and then hit Control and the minus button at the same time. Also Control and the plus button will expand all the layers if you wanted to do them. So there actually are a lot of shortcuts within ArcGIS that you can use to just make things go more quickly. And in your guide for today, I also give you links to the various data sources. So first off is this Alaska Exotic Plants Information Clearinghouse. So this is the invasive species database that is actually maintained here at UAA. It's a huge statewide database, and there's an app that you can download to submit data to it. I've downloaded the app before, but yeah, we're going to download a point file of the invasive species, primarily plants, but you also see that there are some water invasive species that are in this database, and it is quite a large database, so it takes a while to load. You can also add it to your ArcGIS Pro just with a link, but with this link then you don't really have access to the data. I like to always work with shape files on my computer, so as you can see, it's a big data set and the system is slow. Some other sources of data that we're going to use is this, State of Alaska open data portal, and let's see, I think it was State Park Trail. There we go. I found many trails on here, but some of them I could not download. I want to have data I can download and use for analysis. And so I just went here, download. You can see the state parks there. I usually, go to the shapefile and I download the previously generated version. I mean, May 22nd isn't that long ago, and I'm fine and happy with that. So this is one of the data sets that I downloaded. Since we're interested in trails, getting to this issue of how do you look at this at the statewide level, it's basically impossible unless you're willing to spend a lot of time wrangling a lot of different data sources. For example, here's one for the Chugach National Forest. Here's a data file of all of their trails. We have the state park trails, and then you have third-party apps that people use, like Trail Forks here is one that I use, and you can go and you can actually export trails from things like this that you don't find in, say, the U.S. Forest Service database. These are mountain bike trails, but you can switch it to hiking trails. And let's see, we could go to Juneau. I can spell Juneau. This is really embarrassing. There we go. Okay, so we're in Juneau. I'm going to go to this region. And there's a whole bunch of trails, around Juneau. A lot of these actually aren't in the databases when I was looking for them. So you can actually go to these, and you can click on this trail here. And I'm going to go to View Trail. And you can actually save these and export each of these as GIS files. So you can download it as a GPX, a KML, and then either use it on your phone with applications like Gaia, or we can use it in ArcGIS Pro. But unfortunately in Alaska they don't allow us to download a region. Like, I'd just love to download the whole Juneau region, but I can't. It has to be each individual hiking trail. Down here you'd be able to see if they allowed you to do it, and they don't. So we're just going to download some of these. One of your folders contains a whole bunch of hiking trails, and we're going to do something that's called a batch process, which will also save you lots of time if you're trying to do something repeated. Like you want to convert a whole bunch of these GPX files into shape files. Batch processing will allow you to do that. All Trails is another one. Maybe you're more familiar with that. It's a free app that you can have on your phone, but it's the same thing. You can look up different trails, and you can go to them, and you can download them onto your computer download route. So, all right, so let's get to it. Invasive species here. Let's see, I'm just going to start a new map here. Save it to my projects. ArcGIS always likes to be wonky, so I'm going to go to my projects folder. Way too much GIS data. Okay, that's why I'm going to save it, and I'll call it Invasive Species class, just so I know. Alright, hit OK. And in Blackboard, come back, you have an invasive species folder, and right now it's just the student data is there, but I'll get the guide and I'll get the homework all up, but you can find it in the invasive species folder under your course content down at the bottom. Alright, so I'll throw my guide over here so I can walk through it while we do all of this. Alright, so let's add our invasive species data. So navigate to your folder where you downloaded your invasive species information. So it should be under invasive, a folder called invasive, and there you have it. add that. And I know that this is not Alaska Albers because the map projection did not change at all. Alaska looks like it's been pinched to death, and so this is a wrong projection. We don't want to do any distance calculations or anything like that with this data. So the first step is we've got to reproject this into Alaska Albers. Alright, so up to analysis, tools, it's toolboxes, data management, projection, and project. So select your file. I can see the input coordinate system is WGS84. We're going to save our file. So I'm going to go back to my class folder where I have my data stored. Courses. And I've created a new folder where I'm going to store my process data, so I don't really mess with my original data. Alright, and I believe I just want to look and make sure that I call this the same thing that I call it for you guys. So AK Epic Week Observations ALBS for Alaska Albers. Okay? And my coordinate system for me, I'm going to click on the little globe here, open it up, and I have Alaska Albers marked as my favorite. That's what you should project it to, is Alaska Albers equal area conic. Okay, everything looks good, and then hit run. And once this gets added, I don't really want my overall project to be in WGS84. So once this gets done, I'm going to change the projection of my overall project by going to this map and updating the projection of the project. So this will take a little while because, like I said, it's a larger database. And I think one thing while this is going, and it is progressing, I might bring up the color brewer. So the color brewer is the website that I go to figure out what's the best color scheme for my maps. The thing I like about it is you can check colorblind safe, printer friendly, photocopy safe, which can be really important. Like if you're sending things out to rural Alaska, you probably want it to be photocopy safe. Colorblind safe is always a good thing to check. And here you can say, well, how many classes of data do I have? And you choose that. And then you think about your data, and is it sequential? Like 1, 2, 3, 4, 5. Is it diverging? With our outlier analysis, you have cold on one side, hot on the other side. So diverging. And then qualitative. Qualitative is classes. So I don't know, you could have education levels, K through 12, high school, college. That would be an example of classes. And so I use this website a lot, and these codes here that they give you, you can enter these into ArcGIS when you're playing with the symbology and get the symbology to show this yellow and this blue by using these RGB codes here. You probably could use the hex too, but I usually use the RGB. And you can copy these, and what I usually do is I have like Notepad pinned down here, and so I just paste them there, and then I have this up and I go through and update my symbology in ArcGIS Pro. But I'll show you that when we come to that. But this is an extremely helpful website, and I recommend bookmarking it. So come back here, and it's still working on projecting, so again, we'll just wait a little while here. Alrighty, we're finally complete. So as you can see, the projection did not update. So I'm going to remove the former one that's in WGS84. I'm going to change the map properties to the projection of Alaska elvers. I can go up here to the top and layers, and it'll show up because now it's one of our layers. There we go. I'm going to zoom to the layer to see our data. And interesting. They now include a lot of information outside of Alaska in their database, but you can see there are a lot of data points here for invasive species. Okay, so now we have our data, it's in the right projection, and let's explore our data a bit. So look at the attribute table. So project, who observed it, some site codes, revisit, kind of, is it a high priority species, disturbance notes, elevation, your lat longs, how it was collected, GPS, kind of some precision information. For me, the most important, is this presence column. So was it there? Was it not there? Because maybe they have looked at some sites that didn't have it, but that's kind of one of the issues with trying to say predict invasive species is most of the observations are presence only. There's very few absence only. And so if we do select by attributes, we can look and see how many records are actually where the invasive species is present. So presence, invasive species equals 1, that's when it would be a presence, and hit OK. And so one of your questions is how many records have the invasive species present. I won't run through and do it, but you guys can do it, and be sure to write down the answer. If you do see down here where it doesn't show the total number of records, sometimes there's a load button and you have to hit the load button to get all your records to show up. So just in case that happens to you, that's how you solve that. So for right now, I only want to show the database where we do have invasive species present. So I'm going to double click on it and use the definition query. And so I just want it where invasive species are present. Presence is equal to 1. Alright, so now we're only looking at where it's present. Alright, so now let's add the campground to our project. So go to add data, and you have campgrounds and state park facility. Add that. Okay. So that is added. If we turn off the invasive species, zoom in here, you'll see it's just points for where state parks occur within Alaska. And so our goal is to figure out state parks which have invasive species within 1 mile, and what does that distribution look like? What does that mean for actions that we should take? Are there a few campgrounds that have a lot of invasive species, which then you would probably target those campgrounds, and you go a long way towards addressing the invasive species issue? Or is it relatively distributed? So the distribution kind of looks like a bell curve. It's not skewed at all, so you would have to target many campgrounds. But we need to figure that out first. So now that we have our campgrounds added, we're going to put a 1 mile buffer around it. So we'll go to Analysis Tools, and you can either type buffer up here, or I know it's under the Analysis and Proximity and Buffer. So our input feature is going to be our state park facility, and I'm going to save this. And I always like to put the buffer distance in my labeling scheme, so I'm going to call it State Park Facility 1 mile buffer. I just leave off the E because I know it's not going to be a millimeter. And hit save. And the linear unit is going to be statute miles. I'm going to do 1. And Yeah, you could do geodesic. I'm just going to use planner for this because, I mean, it's just points. And the dissolve, you could dissolve, say, on the park name or, you know, some other category in your database. Like if we dissolved on presence, there's only value of 1, so it'd just give you, all the buffers would just be dissolved into 1 buffer. But we want to preserve each of these points, so we're not going to dissolve anything. And then hit run. Okay, so let's zoom in. Always zoom in and check your data. Okay, so I see my point. I'm going to come up here to map, and I'm going to go to measure, and the little measure tool, I'm going to change it to miles, and I'm just going to, you know, check it out. Okay, it's 1 mile all around, so it buffered it to the right distance. I can't stress enough. This is one reason I like ArcGIS Pro over R, is I can see my data and just make sure things are happening correctly along the way. So I do in fact have a 1 mile buffer around my campground. Okay, alright, so the next part is we want to identify the number. Say we're just quick and dirty. We want to see how many state parks have invasive species within a 1 mile buffer. Well, we're not interested in the count, just, you know, of the number of species, just how many parks. One thing that you can do is you can do the select by location, and our selecting features are going to be that buffer, so a 1 mile buffer. And the thing that we're interested in is the invasive species. So this input feature is the invasive species. Actually, I got that wrong. This is actually going to be our buffer, because we're interested in the number of parks that have invasive species within a 1 mile radius. So what we want is, if these are within a 1 mile buffer of your campground, then this should be selected. So if I turn on my invasive species layer, for example, within this 1 mile buffer, do I have an invasive species dot that intersects with that buffer? In this case, the answer is no. So this should not become highlighted. Let's go over to some other spots here. Okay, over here. So I do have an invasive species that intersects with this 1 mile buffer, so this buffer should become highlighted. This one does not. So the input features are my buffer, and the selecting features are the points, the invasive species, and I want to see if they intersect with the buffers. So this is a select by location, the relationship is intersect, and let's just hit apply. Okay, so I'm looking, and it's good. This is highlighted, in fact, this campground with its buffer. These ones are not. And so now you could open up your buffer, and one thing I see is that it's 87 parks. I'm going to go over here to my original park point file, and this should be 87. That's something that's kind of important to check, is make sure I didn't drop any parks when I went and did the buffer, and it didn't. And so, okay, so 41 out of 87 have an invasive species within their boundary. Like, it says nothing about how many, but it's just a quick and dirty, okay, we're dealing with 41 parks here. Okay. Alright, so I'm going to close this, and then I'm going to hit clear. But now say we want to have that more rich information, and we actually want to, you know, count up the number of invasive species within a 1 mile, and we want to join it to our GIS data so that we can make a map where, you know, someone could easily look at it and say, oh, this is an area of the state we need to target for invasive species removal. And so in order to count up the number of invasive species points within the buffer, we use something called the tabulate intersect tool. So if we go over to tools, and under statistics there's this tabulate intersection, And so this will tabulate the number of times that this, turn off my state park layer, that these points from the invasive species intersect with a buffer. You might be thinking, well, you know, why don't you assign, why don't you use the spatial join? So just looking at my data here, why don't I use a spatial join? The problem with a spatial join is, you know, just think about it. Think about your data and think about what happens when you have a point that is within multiple park boundaries. If we assigned the points which park they fall in, you know, what would happen when that invasive species falls in multiple parks? So thinking about how the data and the process works, with a spatial join, you can do multiples, but you're going to greatly expand your data. So, you know, if we did a spatial join, say this point here for this invasive species, it looks like it might be in 3 parks. So if you did something like that and you did a spatial join, this point then would be represented potentially 3 times in your database, 1 for each of those parks, which will balloon your database, create large files, and then you'll have to go and do a summarize to count up by park the number of invasive species. So it's not an inefficient process. It's better to do this tabulate intersection. So let's just walk through it. So the tabulate intersection, your input zone is going to be your buffers. So your state park buffers. So this is, park is represented once, and it's the 1 mile buffer. And your facility name is going to be your zone field. Now this is where I'd be walking through this process and I'd say, oh, this needs to be unique. Because if I'm going to do a join, where I'm going to join back my summarized count of the number of invasive species within each of these buffers, I need to have a unique field in my database. So here is where I would pause, and I'm going to look at my state park facility. Okay, and let's see if in fact facility name is unique. I'm going to see if you can remember how to do it. See, pause, see if you can do it on your own. If you can't, what you can do is you can click on the field and you can go to summarize and just choose any field. It doesn't really matter at all. We could choose region, and statistics type, we could choose anything. All we are interested is getting a count over this field to see if it is unique. ArcGIS, when it does a summarized statistic, always adds a frequency column no matter what you do. So you could just hit OK. And now if this is a unique field, there should be 87 records and the frequency should only be 1. So there are in fact 87 records, and just to be sure, I'm going to sort it, and the frequency is 1. So yay, I'm confident that this is a unique field. It will work for our join later. So we have our zone, we have our name, and we want to intersect it with the invasive species. So we're counting up the number of times this invasive species intersects each of these buffers, which represent state parks. Alright, and we don't need to this sum. I'm going to sum up the presence, because remember that presence field has a value of 1, and so that will give us essentially the count. Alright, and then hit run. You just save it in your geo database, that's fine. In the meantime, I'm going to give my park here a little bit better of a symbology. Let's see if there's any parks. Ooh, a park bench. Interesting. Ooh, I'm going to give it the campground symbology. That way we just kind of keep it separate, so it doesn't look like a point like the invasive species. So we have pretty campground symbology. All right, I'm going to close this down. Let's look at our statistics. All right, so we have 87 campgrounds, so again, good we didn't lose anything. And we have our frequency count, and we can sort it. That is interesting. Okay. One of the things that you have to watch out for is to not open your data files too soon. So if you keep kind of your geoprocessing open over here, you can kind of see when a process is done. So now it is done. Now I can open it up and look at it, and it looks better. It's like, what? All right, and so we can see that we have our count here, the number of presents, and if we sort it, we can easily see which places have the greatest number of invasive species. So I have a question for you guys to answer regarding that, and then also what is the mean and median number of invasive species per in this summarized total. So kind of using your statistics and figuring that out. Also, I'll open that up again. Going to your create a chart and looking at the distribution of your count. I have a question about, how is this data distributed and what might it mean for treating invasive species around campgrounds. So look at the distribution of your presence count here. Okay, so a couple of those. And, I do have a question about this spatial join. Well, why didn't we just do a spatial join? Well, I'll just kind of do it quickly. Let's see if it actually goes. So, I think it's overlay, spatial join, and say we wanted for each invasive species, we wanted to assign it to a park. It's gonna really blow up. It's going to blow up your data. So for each of these invasive species here, we could assign one of these buffers to it. So our join feature would be our buffer. And you would have to change this to one-to-many, because remember I talked about how an invasive species might fall within multiple buffers. So here we're going to do state park, and we'll just leave the default. It's spatial join, and so it's going to, for each of these invasive species, it's going to replicate it as many times as it intersects with a park boundary. So I'm just going to hit run, and I'm not sure how long this is going to take. We'll see. And while that is going, we could go over here and look at this database and see it cut off all the records. So I'm going to hit load all to see how many records we are actually dealing with here. I'm dealing with 167,383. So the database that this is going to create is going to be much, much bigger than that. All right. So while that's running, I'm going to open up the attribute table for my state park facility. So it completed. So let's take a look at this actually, now that it's complete. And I wouldn't recommend, that you do this, because it's not an efficient way to do it. Yeah. And as you can see, it didn't really work very well. Let's look at our state park facility, our buffer. So I'm just looking at these two data sets. Okay, look at this, our invasive species. So 67,833. So it did increase the file size. So you see now we have 167, 637, whereas before we had 167, 383. So in this spatial join it did duplicate the invasive species rows. But now you have to do the second step of, we've got to come over here, and where it joined in the facility name, you'll see some of them are null because, like, ones out here, they don't have any, they don't intersect with anything. So if we select these guys and show them, it's going to be null. But these ones here, if we select these guys, turn this off, these two, we know they're in a park boundary. So we know they're in a park boundary. Turn this back on, select these two. Look at this. See, there's only 2 points. There's actually only 1 point that's highlighted, but it's represented 3 times because it's going to be in 3 different parks. Park name, facility name here. Yeah, yep, Lynx Lake Cabin 1, 2, and 3. And so now, you know, the next step that you'd have to do is you would have to sum up over that field. So you'd have to find your facility name right here, and now you would have to do like a summarize, and by the facility name you'd have to count up, you know, the number of present, you know, the number of times that it's present. So here it's a 2-step process. And creates a larger data set, so you just don't go down this route. Lots of people just use spatial joins when they're really actually not appropriate to use. Alright, so getting back to our exercise, remove the spatial join because I don't want a dirty table of contents. So we have our state park facilities, and our goal is to create a map that shows the count of invasive species around within a 1-mile buffer. So I'm going to open up this attribute table. We have facility name here, and I'm going to look at our tabulate intersection table, and we have facility name here. So we're going to want to join this table to our state park facility. But first I'm going to add a field to our state park facility called invasive count, so I can save that information from the join. So add a field. I call it invase count, and then for the alias I'll put, you know, count of invasive. I can spell it. Count of invasive, and we'll just leave it alone because it's a count. We don't need decimal points at all. And then hit save. Close this down. Alright, so now we do our join. And the field that we have in common is facility name. And the join table is actually our tabulate intersect. Facility name, facility name. Alright, nothing is highlighted. It's all good. Hit clear just in case. Hit OK. Alright, so we should have the count on the end. Yep, and let's save it. And so use the field calculate. Right click. Oh my god, can you make this any bigger? Alright, and we want to go down to count. Really both these columns are the same. Presence, point count, same. Doesn't matter which one you use, and just hit OK. Alright, so we've saved our data. Now we can remove the join. Okay, and so, alright, we have the information as far as the invasive species, the number around each of the state park facilities. So now it's time for us to make a map. Alright. So we could go to symbology. And I'm going to turn off all these invasive species here. So we're going to want to do it based on that numerical count. You know, it depends who your audience is, but there's the ability to show a map that's more qualitative in nature with this data, and then there's the ability to show one that's more quantitative. So there's actually this heat map, which will automatically give you a heat map without you doing any calculations, using any tools. But I mean, you'll see that your symbology ranges from sparse to dense. So, you know, if the public, you know, your audience doesn't really care about the number of counts, then maybe this is the way to go. I can see this definitely is a hot spot here. You know, and up here, cool spots. But one thing that I noticed is that when you zoom in, it definitely kind of changes. Like, oh, now the yellow is gone. So you have to be cognizant of your scale when you use this. So I mean, it's a good map for quick and dirty and not needing to have detailed information, but I would be a little weary about it because the scale thing is kind of wonky, and it doesn't seem like it's refining its symbology here based on your distribution, because like right now in my screen I see nothing that is yellow, which is like, where did my yellow go? So that's interesting. But anyway, I thought I would show you that you can quickly create a heat map by doing that. Okay, I'm going to add some data to this, so you guys should add some data too. I'm going to add roads just so that we can orientate ourselves where we are. So that's part of the public too, is, you know, where am I? Alright, I'm going to drag this down to the bottom. Okay, so I want to have more numbers to mine. I want it to be more qualitative. So I'm going to go back to the symbology. And I want you guys to choose graduated symbols. So graduated symbols kind of distribute features into distinct classes. There's also this proportional symbols. Proportional symbols represent the quantitative values as a series of kind of unclassed bins. I don't really like the proportional symbols. To me, I'm not really seeing where this helps at all. So I usually use the graduated symbols, because the size of the symbol will change based on the bin that it's in. And you can change the number of bins here. Use different breaking methods, change the number of bins. I'm going to leave it as 5. I kind of want a little bit more spread in my size here, so I'm going to change this to 3, and I'm going to up this to 25. Enter. Just, you know, so that these large areas that have, I need to change this, sorry, to count of invasive, so that these large areas kind of pop more. So for the graduated symbols, you want to have count of invasive. I'm going to use natural breaks 5, and from 3 to 5. And so now this is where, you know, if I'm trying to relay information to an audience, why not get them 2 ways? So visually we can do it with the size of the bubble, but we can also do it with using the color brewer and add some colors to this. So this is actually something that's sequential, so it's going from big to large. So I'm going to go back to my color brewer, not to Facebook, and I'm going to hit sequential, and I have 5 classes. I want it to be colorblind safe, and maybe I want to make some printouts of this, you know, some information about invasive species. So I'm going to choose this first blue one. I want you guys to choose something else. You're going to make a map of this. I'm going to hit copy, and like I said, I'm going to paste it here so I have it. So I have my from light to dark, and move this over off the screen and go back here, and okay, so I can go to this first symbol and I can right click on it, and I can go to color properties, and if this isn't at RGB, change it. And now is where I can put these in. So 240, 249, and 232. So 249 and 232. And I just hit tab to get between them, and I can see, okay, it did update my color. What I can do is go like this, just so you guys can see it. Right click, color properties. Alright, so I want 186, 228, 188. Okay. The next one, right click, color properties. I want 123, 204, 196. Right click, color properties. I want 67, 126, 202. Alright, and the last one. 8, 104, oops, 172. Okay, so you guys will have one of the other color schemes that's here. You just click on it to get your numbers here. Okay, so I'll go back and make this big. So now I have a map that not only reflects size but also color. And so you can really see, alright, there are some campgrounds that we need to target here outside of Fairbanks. But this is maybe the Chino Lakes area, is this? Quartz Lake, Big Delta. So Big Delta especially. Oh, I've been to that campground. Ha 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 ha. And then down here, south of Denali, we've got some facilities here that have a lot of invasive species around them to target. It's called Denali. Okay, so I would like you to make a map showing me the color scheme that you came up with. You can just take a screenshot of it and remove the labels because the labels are annoying. Yeah, and so this is a way we easily calculated, we identified how many campgrounds have invasive species within a mile buffer, what is the count of invasive species. You're going to look at that distribution, tell me what it means as far as where do we need to target. You know, we have to go after a few bad eggs, or do a lot of them have problems, and then make a map here. So the next part is this roads. You know, is there an influence of roads on invasive species? So for this, we're going to remove our definition query. Not from this layer, from our invasive species, because we want to look at both presence and absence. So remove this definition query. Okay, because we want to look at the distance. What we're going to do is we're going to calculate the distance from the road to invasive species points. And the idea is, you know, we could look at points that have invasive species and points that don't have invasive species, and see if there's a difference. But overall, I think with this data set, we're going to be kind of limited to looking at, you know, what points that have invasive species, because like I said, it's missing quite a few with no invasive species present. So in order to calculate the distance from your invasive species point to the road, nearest road, we use something called the near tool. So we're going to go up to tools, and it's actually in this first analysis toolbox under the proximity, and you'll see near. There is a different tool that's that can calculate multiple near locations. So if you are interested in, say you had an issue where you wanted to find all the nearest locations, say among all invasive species, you wanted this huge distance matrix of the distance between them all, that would be a different tool. That would be this generate near table. That would be a massive table. It'd probably crash your system. We're just interested in what is the distance to the nearest road. So for this one, it's going to calculate what's the nearest straight line distance to this road. It's not interested in this road at all because it's too far away. And when we get like in here, it's going to, you know, trying to figure out, okay, this point here, which one of these roads is the nearest, and it'll just calculate one distance for the nearest to a road. So we'll double click on near. Your input features are going to be your invasive species. Your near features are going to be your road. You can limit it to a search radius, like say for example you're not interested in places that, you know, are 100 miles off of a road system. You could do something like that, and then you would limit it to, you know, 100 miles. We're not going to do that here. We just leave it blank. You can get the angle and location, so if you're interested in, you know, is it typically have a north direction, east direction, you know, you can get the angle. Since we are covering a big area, I'm just going to do the geodesic here. And then we'll just, you know, it's going to have your near FID, which is going to be the feature of the road. So it's going to identify what road is nearest. So if you look at your road attribute table, ArcGIS always adds this FID. It's not a permanent ID, so just be aware. If you're depending on this FID, it's often a good idea to make a new column and save it. But it's going to give us a table where each point is going to have an FID, a near FID, and that near FID corresponds to this number in this road table. So if you wanted to find all the points where the nearest road was the Glen Highway, you would be able to figure that out. And then it'll add a field called near distance, which is going to be the near distance. And the unit, we'll just do the unit as meters. You can change this name, so you know it might be helpful to put like a, you know, change this to be like you know, distance meters, something that makes sense to you. But we're just going to leave the defaults and hit run. Make sure nothing is selected and hit run. So right now it's figuring out what is the nearest road, what is the ID of that road, and what is the distance in meters. So it might take a little while to run. Well, that's running. You can always, you know, use Google to look up these tools that we're using. So near analysis, you know, ArcGIS actually has some pretty good help and overview of their tools. So, you know, this is an example of the input feature, the nearest distance, your nearest feature, and just talking about the near angle that I had mentioned before. You can then also figure out what type of data, what does my data need to be to do this. So you can actually calculate between points in a line, points in a polygon. I'm not quite sure. You can do mixed feature types, so here's a line and here's a polygon. So basically anything that isn't a raster you can do near features with. So yeah, by Googling it's a very helpful way to figure out more about these. The near table. The near table, as I mentioned, it's funny. It's looking at wells 500 meters off of roads. I actually did this analysis for the state of Alaska, looking at oil wells and approximately how far are they from road systems. And so this basically identifies this in FID, I can tell you, is going to be the well ID. This near FID is going to be your road ID. And then this is the distance. And this is the XY coordinates of where that well was, the XY coordinates of where that near point on the road was. So say you're doing field work and you're like, where do I need to stop on the road to have the quickest way to get into my well? That's what this is. And then what degree do I have to go? It's a 20% degree. So you can do, say, a join. If you wanted to bring back in what was the name of that well, this would be the column that you would use. If you wanted to bring in what was the name of that road, then this near FID is what you'd use to bring in the name of the road. But like I said, this is going to give you all your pairwise distances between all the roads and all the wells. So I did this once and I had 15 million records. It bogged down my computer a bit. And as you can see, even just running the near tool takes a long time, because with this point, it's got to figure out, look at all these different roads it's got to look at, and then do the calculation of what is the shortest distance. And if I save the angle and location, that's even more data that it's trying to do. So I'm just gonna pause this while it sits here and run, and you guys can probably take a little break on your end too. Alright, that took a long time to run, so let's look at the view details. It took nearly a half an hour to run. So just a word of warning, it's going to take a while to run. Alright, so let's look at our results. So based on this, it's going to have appended this near FID and this near distance. So looking at the guide that I put together, I actually did call this distance M. I usually do rename it so that I can tell what it is later, so I'm not going to rerun the half an hour tool. So let's look at our invasive species. Let's open up the attribute table, go to the end, and here we can see, the near FID, and we can see the near distance. Okay, and so let's zoom out a bit here. All right. So, let's say that you're interested in finding out the number of invasive species points that are along the Denali Highway, which is this road here. Take a look at this, and I'm going to select a segment of this line. It's all highlighted. So the Denali Highway. Let's look at the Alaska roads. Let's look at that feature. It's not even named. So this is the Denali Highway. Alright, and so I will see that it has an FID of 7725. So this is the Denali Highway. What I want you to do is I want you to select it, and I want you to figure out how many invasive species observations are along the Denali Highway and how many of them have presence. So okay, so in order to do that, remember it's this joining function. So we have an FID of 7725, and so we go back to our invasive species database and see this near FID. We should select the attributes that have a near FID. That is 7725. I'm just going to expand this to make sure it's not more. So 7725. And then hit apply. So this in theory will select all the points where the nearest road is the Denali Highway. Okay. And so when we look at our data, let's turn off the roads. Sure enough, we can see all the points where the Denali Highway is the nearest road. Now, some of them are kind of silly. I'm not really going to access these points from the Denali Highway, but this brings up the issue of what is the roads layer you use, how do you define access. If we have rivers look to be highly important for invasive species. Clearly there's another road that goes off here, so how many are along the Denali Highway? Well, you have your answer by the number of roads that are selected. Okay? Alright, so I'm going to hit clear. The other thing that I ask you to do is I ask you to figure out what is the average distance among all the observations, so doing the statistics on it and looking at the calculated statistics. What is the average distance for all observations, and then what is the average distance when you actually that's what I ask you to do. We don't look at observed, that presence equals 0, presence equals 1, because it's such a small data set. It's not worth it. So so I ask you for the distance. What is the average distance? Okay. All right. Some other things. Remember I talked about how we have roads, but looking at the distribution of invasive species, I would say that probably maybe trails are important too. I mean, we see what's going on here. Something's going on here. It's obviously not a road that's influencing our distribution of invasive species. Here too. All right, so let's add the Chugach State Park trails. So if you go to your student data, trails, you have Chugach State Park here. You see that Chugach State Park is a KMZ. Just looking at. Okay, so we can't add a KMZ directly to our map. We have to convert this. So go up to Analysis, Tools, and it's going to be under Conversion Tools, and we're going to do a KML or KMZ to a layer. We're going to navigate to that Trails, Chugach State Park. And whenever I do the conversion of a KML to a layer, I always just accept the default output. It's not worth saving because it's going to look weird, as you will see. Close these down. Map. Hit clear. Okay. Alright, so the Chugach State Park is very nice in that they actually give you a lot of GIS data for the Chugach State Park. You can Google Chugach State Park and you will find, we went to the National Forest before, but you will find that they actually have KMLs and it's representing points, polylines, and files. So I'm going to turn off the polygons. That's the state boundary. I'm going to turn off these line symbols for now. So you have points that represent like cabins, campgrounds, hiking trails, trailheads. So I'm going to turn off the points, turn back on the lines, and take a look at this. I'm going to make my lines a little bit more colorful here. And I mean, it sort of looks like the hiking trails, which within the Chugach State Park kind of influence invasive species, This is a pretty popular route going out to here. I don't know if this is Symphony Lake, what this is. I don't have a whole lot of time to get out and do a hiking. But out to this lake there are some. So this is just an example of where, if I went and Googled, Chugach State Park GIS KML, you're asking how I find these weird data sets. Just lots of GIS words I throw in there. You can download actual KMLs for Chugach, Denali, Ketchimak Bay, Cairns Head, and you can actually open these on your phone and navigate with them if you're out hiking. So it's a good resource, but this is an example of if we're really looking at this invasive species, we got to go after different data sources. Okay, so I ask you for your interpretation of whether you think this trail facilitates the spread of invasive species. Now let's look at a different trail network, Camel Track, which is within Anchorage. Well, I'll turn off Chugach State Park, turn off my invasive species, and turn off the roads just because. And here's Camel Track. There it is. So now does Camel Track look like it influences invasive species? And I would say more so. And so I ask you about that, your interpretation, and why you think maybe invasive species align better with this trail network than the Chugach State Park trail network. One of the things that I'd mentioned in the intro is, say we wanted to turn on multiple of these layers. One thing that you can do is highlight Camel Track, hold the shift down, go down to roads, click, let go of shift, and hit the space bar. Just turns them on and off. And with them highlighted, if I wanted to expand them all, I could hit Control plus. Oh, actually, let's see if it works. Control minus collapses them all. Control plus expands them all. So with them all highlighted, Control minus. Just because I've worked with you guys, and sometimes this can get pretty out of control. Even in my projects, I can have like 40 rasters at one time, and I just want to collapse them or turn them all off. So that's a shortcut. So the last thing that I want to do with this is I talked about this batch command. And one of the problems, with doing this analysis is there are so many different data sets. There's really no complete one-stop all trails, file, GIS file for the state of Alaska. So I went and downloaded a whole bunch of GPX files. So GPX files are what you're going to get off of your GPS unit. So when you go and record something with your GPS unit, or even your Garmin watch or whatever you have, it's going to create a GPX file. And so if you look at your data, student data, you have GPS hikes, so a whole bunch of GPX. What we want to do is I want to show you how do I take all of these and convert them into a shape file. Each of these is going to be converted into a shape file rapidly. So it's this batch tool option, which works with any tool in ArcGIS. So go to GPS, GPS to features, don't click on it, right click on it, and go to batch. So we don't want to save our batch tool. This is just temporary. We're not going to need to be repeating this. So save everything just as normal, and then hit next. Now you want to navigate to those GPX files, so hit the browse. So it's under student data, GPS hike, and click on the top one, hold the shift down, click on the bottom one. So you've selected all of those. What is it, like 12 files or something? Hit OK. And so rather than convert these one by one, we're going to convert them poof with a click of a button. One of the keys is this, what is it, percent name percent. This is kind of like a Python code, and what this does is it grabs the name of your input file and it keeps it. And so all the files will be renamed with the original name, and in this case it's adding this GPX to feature. I think that's a little bit much. So I'm going to copy this percent name, so Control C, or copy. I'm going to navigate to my folder here, and I'm going to paste in this. And so what it's going to do is it's going to create new files with the exact same names, but they're going to be shape files. So I'm going to hit save, and I want it to be aligned because these are hiking routes, not points. So name, tracks as polylines, hit run. And so with the click of the button, it is running through every single one of those GPX files and converting them. This will save you a lot of time with any tool that you use in ArcGIS if you have to do it multiple times on a process. So I probably didn't know about that for like the first 10 years. I was like, really? Why didn't somebody tell me sooner? And as you can see, they're all added here to your map. So I think I went and grabbed some just from various places around the state because these are missing. They're not in a trails database for the state of Alaska. You know, and now I can turn on my invasive species. You know, and I could do maybe a better analysis. Like clearly this trail up here around Fairbanks is a vector for invasive species, whatever this guy is. What is it? Trail planner map. That's what that route is. So, and I think I went and grabbed some for the Juneau area here too. Wherever Juneau is. Juneau's somewhere down here. Yeah. Oh, I grabbed one because I saw this trail and was curious if it was a vector for invasive species, but it doesn't look to be. But anyway, so the difficulty with doing, you know, some type of prediction with invasive species is that multiple things affect it. It's getting a complete data set. You're probably never going to get a complete data set at the statewide level, and this absence data, you know, putting a sampling effort to collect absence data is pretty difficult. Okay, all right, so I'm gonna actually turn all of these off. So click the bottom, click the top, hit the space bar, and then I'm going to collapse them, Control minus. All right, and so now I'm just going to remove them because I don't need them for the rest of this exercise. So keep everything kind of clean. I'm also going to remove Camel Track, State Park. I don't need these at all. Okay, so for the next part, we're actually going to use a new tool. And it's something that I used for my PhD work. And what we're going to do is look at, you know, Juneau, let's say, is planning to put in a string of cabins, and they want to calculate what is the route that it might follow. I use this for, it's called least cost path, and I used it to look for moose dispersal when I was doing my PhD up at UAF. And so in this process, it's a complicated process. And so I'm going to introduce you to something called Model Builder. And Model Builder is exactly how it sounds. It's you build a model with multiple tools strung together to ultimately get your output. And you can save this, and then you can open up your project and rerun your model, you know, later on. It's a great way to preserve the steps that you do for an analysis, and it's a nice visual. So I can show this to someone in a presentation. They can look at it and they can say exactly what I did. In this case, what we're going to do is we're going to take a DEM, so a digital elevation model, and we're going to create the slope with it. And then the slope is going to be used to calculate a cost distance, both cost distance output raster and this thing called a backlink. This cost distance will represent the cost distance from, say, our start cabin, and that'll be as assessed by slope. So the cost will go up as the slope, you know, accumulates and gets more and more. And this backlink, this represents if you had to turn around and go back the way you came, how costly would that be? This backlink is actually kind of important because programs like QGIS and R actually don't incorporate this when they're doing their least cost paths. And so that's why I prefer ArcGIS. And so both of these, this cost distance based on the accumulated slope from your starting cabin, along with the penalty for turning around, go into figuring out what is the least cost path to your end cabin, where I would have to go over the least amount of ups and downs to get to the other cabin on the other side. And then all of this is raster based. The final step is you've got to convert it into a shapefile or a line. So we are going to work on this. One of the keys that when we're doing this is, remember how we just used those dollar signs, or sorry, percent signs, Python coding? We're going to be using these percent signs and saving things to your Scratch workspace. So this is the line of code we're going to be copying a lot here. And this is so when you share a model with someone, they can easily run it because everyone has a Scratch workspace when you start up an ArcGIS project, and it's all named Scratch Workspace. So they could just run the model as long as they had access to the GIS files. Okay, so that's a summary of what we're going to be doing. One of the things when reading a model builder is the yellow rectangles are the actual tool, so the names of the tools. The blue is the data that's going into the tool, and the green is what is being produced by the tool. Okay, so let's go back here. All right, so we have our ArcGIS. Okay, we need to add on our DEM. So DEM, you'll see this is a 10-meter digital elevation model. It's produced by the Arctic Center. They even have smaller ones that are like 1 meter. Let's see, Arctic DEM. And so it's an outfit out of Minnesota. And so they've put a lot of money into gathering an Arctic DEM. There are some patches, as you saw, but they have them at various resolutions. I mean, 30 meter, 10 meter, even 2 meter resolution. So this is kind of, if you're looking for digital elevation information, this is the place to head to get it. But as you'll see for the Juneau area, Juneau's kind of cloudy. There are some missing patches here where they just haven't been able to fill it in due to cloud cover. Okay, all right, and so let's take a look at this DEM. Let's go up to raster layer, and then symbology, and let's do shade relief, just to get an idea of how hilly is Juneau. Okay, so where is Juneau? All right, so here's the kind of the airport and the town right here. We'll turn this back on. There we go. All right, well, we can see, you know, flat out in the ocean areas, but definitely a mountainous area. You can see the ridge lines here, valleys and stuff like that. So we have a good, suitable DEM that I'm happy with. I'm going to add on our potential cabins. So go back to your student data, campgrounds, and put new cabin start, new cabin end. Okay. Double click on your symbology. I think they might actually have a cabin. Campground. Oh, yeah, let's do a little campground for our start, and then for this one, we can do, what is it? Tents. Let's just do a different campground symbol. There we go. That way we can see them. So the start campground is down here, and our hypothetical, say, end is up here. So what we're trying to figure out is what is the path that a hiking route or road might take to connect these two. And so we're going to use our slope to figure out what is the path with the least resistance as far as slope goes to go up here. And you can add other factors in, other layers, like you could add, I don't know, roads in here. You could have different barriers of cultural, anthropological sites, like say you didn't want people to walk in a certain area. That could be included into your least cost path analysis, forcing people to go around, say, a culturally sensitive area. You can add anything to your cost raster and then draw your path. So, okay, we have our start cabin and we have our end cabin. All right, we want to do this in Model Builder. So go up to Analysis, and you'll see something called Model Builder here. So we'll click on it. And it opens up kind of your, I don't know, I'm not a painter. What is it? I don't know. You have an easel and you have like stuff that you paint on. So your platform to do your paint on. The first thing that we want to do, so not an artist, is take our DEM and turn it into slope. So there is a tool for that. So we'll go to Analysis, Tools, and you can just type slope. Alright, so we wanted to do this spatial analysis tools. The key is click on where it's located. So click on where it's located there, and then click on it and drag over to your canvas. That's what it's called. Your canvas, your model canvas. Alright, and so now we see something where it creates a slope. And so when, see these boxes around it, it's highlighted, I can move it around, they all go together. If I click off of it, then nothing is selected. If I click on this one's selected. I can move it all around. Alright, so we have our slope. The input that we need for the slope is our digital elevation model. So what you can do is you can click and drag to your canvas, drop, let go, and then this is your input raster. Okay? Alright, and so I'm going to right click on this and rename it. This is going to be our slope. So just type and then hit enter. Okay. Should update it. Oh, I didn't. It's acting weird. Okay. Let me right click on it again. Rename. How about slope 2. There we go. It probably didn't want to be called slope because this is called slope. I'm also going to right click on this when it's highlighted and put add to display. That way when I run this tool, it's automatically going to be added to my map, so that way each step I can see if things are happening correctly. Okay? And if I double click on this tool itself, here I can get what's going on. So it's taking the input raster of the DEM and it's creating an output raster. This is really what it's calling it. And the methods that it's using, I'm all fine with this. This is fine. Right now, this is just going to be stored in the default geodatabase, a temporary spot, which is fine because I don't really need to save it right now. So I can click on this slope. It is selected. And there are two ways to run a model. I could go right click and say run. That's one way to do it. I can come up here and I could say validate, and it's going to validate the model, and then I could hit run. When I do that, it's going to run all the processes in here. If you don't have anything selected, it's going to run everything. So I prefer to just click on this, and I'm going to right click and then hit run. Okay? So this will be the first step in our least cost path analysis, where we're figuring out what is the slope around Juno based on the digital elevation model. So step 1. And when it's done, it's going to add it to the display and we can take a look at it. I can click on this close. I probably should click close on completion, because that way I know when it's done it pops down. And it gave us a little warning. That's fine. Go back to our map here. And okay, so now, I mean, these are really high scale DEMs. I can see the buildings actually in Juno. Yep. I can see the rugged slopes here. So I'm happy with the creation of our slope. So we've got our slope. It goes from, you know, less than 1.7% slope all the way up to 90% slope, basically straight up. Okay, so we have our slope layer. Let's go back to our model. Okay. The next thing, one thing that I want you to do is, I'm interested in what is the mean slope, say, for this area. These digital elevation models come in like squares, you know, where they process data. So one thing is to look at the properties of your slope, and you can go to it and you can look under source, and then if you look under expand the statistics tab, that's where you'll be able to find out what is the mean, what is the max, what is the min slope for the Juno area. So I would like you to tell me what is the mean slope for the Juno area. So look in there. Okay. Alright, so now we're going to go on to the next step in our process of calculating the least cost path. So we've done the DEM slope, we have a slope raster. Now we need to calculate this cost distance. You know, there isn't just an easy tool in ArcGIS to say, give me the least cost path. It's actually a quite complicated process. So we're going to search for cost distance. Okay, so I see cost distance in this spatial analyst tool. I'm going to click on where it's located. I'm going to come back here and find my model. If you lose your model, one good thing would be to save your model with a name that you recognize. So you can come up here and go save as, and you could call it least cost path. This is going to save, all models get saved in a toolbox. It has to be saved in a toolbox. It can't be outside of a toolbox. And a toolbox is this little red thing with a hammer on it over here. These are all tools, which are kind of like models within a toolbox. So this is saved within our project's default toolbox. So I can hit save. And one person who was using this was like, oh, I can't find my model. Okay, you can't find your model. Don't panic. The way that you can find your model is you can go to View, you can go to Catalog pane, and your project is here. In your project, you can see we have one map. You can see the different data sets that we have in our project, but it also has a toolbox. So it will be within this toolbox. And if it closed for some reason and you need to open it back up and edit it, you find your model, you right click on it and hit edit, and it'll open it up in here. For me, when I'm doing this for my research projects, I have a toolbox that I save my tools in. So if I go to, say, my Aura project that I have, you know, I have a GIS folder, and within my GIS folder I have, you know, like tools. And so this is where I'm saving tools that, you know, I want to preserve outside of some, you know, project that I do. It's in a toolbox specific to a project. But anyway, just in case your model disappears, don't panic. Go to your catalog pane and go to your project and you'll find it there. Alright, so let's go back to our geoprocessing where we're looking at this cost distance. So click on it and drag over. Okay. So for this cost distance, it needs the slope as the input to get the distance from cabin number 1, the start cabin, and then to create the backlink. So I'm going to click off of this. I'm going to click on slope and I'm going to drag and hold, and then I'm going to make the arrow connect and let go. So this is going to be your input cost raster. The slope is the cost. As I mentioned, you could have an input of, you know, a slope plus an anthropological site, a slope, and if roads were a barrier. You can make this cost input raster a combination of many different rasters using the raster calculator. We're keeping it simple and just using slope. So we need to calculate this cost distance from the start cabin. So we have our start cabin here. Click on it and drag it to your canvas and drop. And now, like before, click off of it and then click and hold and then drop, let go. And so this is your input feature source, the cabin start. You can click on these and, you know, arrange the size. Okay. And so this I'm going to rename. Right click and I'm going to call it cost distance. Hit enter, and I want to add it to my display. Right click, add display. My backlink I'm going to rename, call it back link. Okay, I'm going to add to display, and I notice that it's gray, which means it's not happy. So let's double click on our cost distance tool and see why it's not happy. So my output distance raster. Oh, that's right. One of the things that I wanted to show you was this idea of using this Scratch workspace, so that if you gave this model to somebody else, they could just run it. So I can, in your guide, you have this Scratch workspace. So what I'm doing is I'm going to copy it, and I'm going to come over here and delete everything and paste it, and then do a backslash, and we'll call this cost distance. And I'm going to come down here, do the same thing. I'm going to paste Scratch workspace, backspace, backlink. Okay. Link. All right. And then hit OK. All right. So now it's happy. So when you look at it, you should have, this is going to store it in whatever default Scratch workspace you have, and it's going to call it cost distance. It's going to store it in whatever Scratch workspace you have and call it backlink. Okay? Whereas if we go and we look at this slope one, this one was actually stored in a specific path. So it's stored to my G projects, invasive species, something hardwired on my computer. So if I shared this model with someone, it would break at this slope step because they don't have this path on their computer. So if we wanted to share this with a friend, we would basically want to delete that, put the Scratch workspace, backslash, and call this slope. Okay? So everything is looking good to calculate our cost distance. We're going to get our cost distance, which will be the kind of cumulative slope from our start cabin, and we're going to get our backlink, which is the cost for if I need to turn around. I only want to run this tool because I've already run this one. I don't need to run that anymore. So I want to make sure that add to display, click on this tool. When this tool is highlighted, right click and hit run. Check the close on completion. And these do take a little while. I mean, it's calculating a surface for the extent of what the slope was. I'm just reading what it's all doing here. Working away. And yeah, this is a tool that, you could use, for, planning, paths around Anchorage, planning where, animals might be going through, neighborhoods. Like I said, I used it for moose moving around the landscape. Obviously, it's got lots of different uses for it. Alright, so it is done. And we can go back to our map. And I'm going to use the handy little trick of click, hold down, shift, click, and control minus to collapse. Okay, so now it actually did rerun the slope. I'm just going to turn off the slope, we don't need it. I'm going to turn off this backlink one. So if we zoom to our start cabin, so this is basically a cost distance showing what is the cost from our start cabin, which is buried. I'm moving it up to the top, moving it up to the top. And so you'll see the green near the start cabin because, you know, the accumulated slope is lower, and then as you move further and further away from your start cabin, your cost gets greater and greater. Okay? And the backlink looks like, I don't know, someone's on LSD here. Kind of shows you, okay, if you had to turn around, are you going to have to go left, right, what direction are you going to have to move in order to get out of whatever sticky situation that you're in. So it just helps when it's searching through the algorithm to try to find what is the least cost path, and I get turned around, which way am I going to have to go. So if I get turned around here, I'm going to have to move to the upper right. Okay. But the idea is, it looks like we have a solid surface, so now we have our two rasters. These are rasters that we're going to need for the next step. Okay? Alright. So the next step is actually calculating our cost distance. So our cost path. So if you don't see it over here, type cost path, you'll find it. So once you find it, click and drag over. So this is our cost path now. And so the inputs for our cost path, cost distance. So this is our cost distance raster. Click on this one, drag in. This is our input cost backlink raster. Okay. All right. And so again, we want to use that scratch space notation. So double click on your cost path. And your output raster here, I want you to, you can copy this from the guide, but it's going to be, you know, percent scratch capital work space, percent back space, and least cost path. Okay, so hit OK. You'll notice it's still gray, so it's still not happy. We need to tell it where is it going to draw the least cost path to. So that's where we need to find our end cabin, and highlight your end cabin and drag it over here. And now click, hold, and drag in, and this is our input destination, feature destination data. So there we go. Oh, now it's looking happier. Alright, let's rename our output raster to something that makes more sense. So right click, and you can say least cost path. Okay. You can click and make these wider. Alright, and we want to add it to display. Okay. Alright, so now everything looks happy. We've got our cost distance in, backlink in, new cabin. So click on this and then hit run. Okay. Alright. So let's go look at our map. Turn off the backlink, turn off the cost, and turn off this cost. Alright, so I can see that we do have a little path drawn here. One thing, you know, that I notice is that it's green, so it's given the value of 3. I'm not exactly sure kind of why it does. If I look at the attribute table, so we've got 452 cells that are a value of 3. This is basically our path right here. This is indeed a raster. If you right click on it and go to properties, I can see that it's a raster. So not quite exactly what we want yet. What we want is just a nice shapefile, a nice line, where we can then calculate what is the total length of our path that we might put in to influence, you know, invasive species spread. So good, we've got our path here. All right, just gonna clear everything. Go to the least cost path, and now we need to convert raster to a line. So you can come up here and hit convert raster. And so to line, let's see if it comes up. It's going to be in the same toolbox as your conversion tools, raster to point. I guess this is polyline. So yep, raster to polyline. So under conversion from raster to polyline, so click on it, click and then drag over. Okay, so your input raster is going to be your least cost path. All right, and again, we're going to save this to our Scratch workspace. So double click on this. All right, so you're going to save this, your polyline feature. So we could call it LCP trail. And then click on this, and I would just rename it to something that visually looks better. Least cost path trail. Okay. Add to display. Okay. So now let's convert this. Or sorry, let's run this part of the model. It's running. The red means it's running. And the red also means that you have problems. So let me double click on it and look again. I think I know what the problem is. I am going to take off this .shp and just hit OK. And then try it again. Click on it, and then I'm going to try to run again. And it didn't like that .shp. Just wanted to give it its own. Alright, so we have it added here. Let's go to our map. Turn off the grid. And sure enough, here is our new trail. So based on the least cost path, the slope, this is the trail that would be put in to connect these two cabins. This is the area to be impacted by invasive species. So your final question is, how many miles long is this trail? So what I want you to do is, I don't know why it gives you 2 here. I mean, if you look at it, one of these is the little tiny start right here, and one of these is the full line. Eventually, to clean all of this up, you would do a dissolve based on this node to get it all down into one single path. Actually, I'm just going to do that because it's annoying that it created 2 lines when we just really want 1 line representing our trail. So I'm going to clear these attributes. I'm going to go up to Analysis and Tools. And then I'm going to search for dissolve. Okay. Since this is a process in our model, I'm just actually going to add it to here because it needs to be done. So the input is going to be our trail. And I'll double click on it. The dissolve field is going to be that 2 node. So if I take a look at this, that 2 node was just values of 2, so it's going to dissolve over 2 and just make 1 path. Alright, and the output, I'm going to call this LCP trail v2 for version 2. Okay, and then I'm just going to hit OK. I'm going to hit run. Actually, I need to add to display, and I want to rename this dissolved LCP trail. Okay, so now I could click on this. Click on this and hit run. Okay, so now let's take a look at our map and look at this. Should just have one. Okay. Alright, so now I want you to calculate the total length of this line in miles. So you guys know how to do that. You add a field, a double, use the calculate geometry, make sure you calculate it in miles, and tell me how many miles long this proposed trail would be between these two hypothetical cabins. So there you go. You learned a lot today. You learned how to calculate the distance between points and lines. You learned how to batch convert files. You learned Model Builder. And you learned a bit about how to do a little Python coding and grabbing the names off of existing files. So it's a busy week. I hope you enjoyed this exercise, and I'll see you later.